Determining rate of change or slope and y-intercept from a graph. Let's look at number 1. Triangle ABC is shown on the coordinate grid. Find the slope of AB. There are really multiple vocabulary words in that statement, but I want to go ahead and focus on slope because we talked last week about the formula for slope. We said that it was y2 minus y1 over x2 minus x1. And we said that it compares vertical change to horizontal change. A lot of the time, people like to call that rise over run. Now, when you look at this triangle, you might not think, oh, this is where I need to find the slope of a line. But I would say that triangle problems are actually the easiest ones to find the slope of a line because you can use the triangle. Let me show you what I mean. So I'm going to look at the distance from B to C, because that would be our vertical change, right? We would call this our change in y. I could actually just count this and see how many units it is. 1, 2, 3, 4, 5, 6. Okay, so our vertical change is 6. And if I look at the direction of the line, as we go from left to right, it's going up, right? So that should tell me it has a positive slope. Now let's look at our change in x. So it's right down here, right? That's our horizontal change for this line. That's 1, 2, 3 units. So we could say our horizontal change is 3. So now when we want to use our formula, we really don't even have to use y2 minus y1 and x2 minus x1, because that's just a fancy way of calculating the change in y divided by the change in x. Well, we know that's going to be 6 over 3, which is 2. So really, we already know the slope of this line. Let's go ahead and substitute some points into this formula just to be sure, though. So the points I'm going to use are A and B because those are the endpoints of the segment that I want to find the slope of. Remember, I wanted the slope of AB. So let's look at those ordered pairs. It looks like B is 5, 9. You always want to start out by labeling those. And then A is 2, 3. Okay, let's do the labels on them. We have x1, y1, and x2, y2. It does not matter which point you choose to be 2 and which point you choose to be 1, as long as you do the same thing every time, as long as you're consistent. So now we're ready to substitute. y2 is 9, minus y1 would be minus 3. And then in our denominator, x2 is 5, and we're going to have 5 minus 2 because x1 is 2. There we go. So 9 minus 3 divided by 5 minus 2. 9 minus 3 is 6, and 5 minus 2 is 3. Well, look at that. That's what we found when we looked at the horizontal and vertical legs of our right triangle, wasn't it? So 6 over 3, that's equal to 2. So it's the same result we had earlier. The slope of AB is 2. Let me see where I can actually see that on this triangle. I'm going to erase my work here so that we can see where we see 2 over 1. Okay, so I see as I look on this line, let me highlight the line. That's what we found the slope of. I can go up 2 and over 1, up 2 and over 1, up 2 and over 1. Whenever I go up 2 and over 1, I land on that line. That's why the slope is 2. Remember, if I wanted to write 2 as a fraction, it would be 2 over 1. That's why it's the slope of our triangle there. Okay, let's look at the next one. This one does not have a triangle, and that is okay. We don't have to have a triangle drawn for us to be able to find the slope. But one thing that this diagram gives us that might be a little challenging is we have to decide which points to use. It doesn't tell us which points to use. So when you get to choose the points, you need to pick a pretty point. Here's what I mean by that. This point's pretty. The reason it's pretty is because I can tell exactly what it is. I know that this point is 1, 2. That makes this point a pretty point, right? Okay, let me show you a point that's not pretty. This red one over here. Why do you think this point might not be pretty? It's because I can't really tell what values it is, right? I know it's somewhere between -2 and -3 for my x, and I know it's somewhere between 5 and 6 for my y, but I can't be sure. I can't be precise in labeling this point. I could guess, but it could be a little bit more than halfway to the left or maybe a little bit more than halfway towards the top. What I want is a point that is right on where two of my grid lines meet, because then I can be absolutely sure of what that value is. So I have one good pretty point over here, and I just need to choose one more. I think I'm going to choose this one right here. So this one has, let's see, that's -3, 6. Awesome. You need 2 points to find the slope of a line. But really, there's a lot of good points on this diagram, aren't there? Okay, so let's use those two to substitute into our slope formula. I'm going to label them x1, y1, and x2, oops, that's not a 2, x2, y2. Let's substitute. We have y2 minus y1 over x2 minus x1. So y2 is 2, y1 is 6, and then x2 is 1, and x1 is -3. There we go. We're ready to subtract. 2 minus 6 is -4, and 1 minus -3, that's the same as 1 plus 3, so that's 4. So that is -1. This line has a slope of -1. And of course, there's more than one way that I could have found that, right? Like, one thing I could do, now that we know that we can really just draw staircases to find and describe the slope, I could start at, well, you know what, let me start at one of those pretty points I chose. I could start at a point, I can go down 1 and over 1, down 1 and over 1, down 1 and over 1, and I always land on the line. So when I draw some labels here, I can see I went down 1 and I went over 1. I went down 1 and I went over 1. I went down 1 and I went over 1. So my change in y divided by my change in x is just -1 over 1, which is just -1. So that's where I can see the slope in here, and I can also see another way that I could have determined the slope. I could have drawn my little stairs. I also want to point out that we know that the slope would be negative from the very beginning, because if we read from left to right, this line is going down, and we always read from left to right when we are interpreting graphs. Now here's the easy part. If you ever get to answer a question about the y-intercept, just be happy, because it is so easy to find. Let me clear out some of this work. There we go. So when you have to find the y-intercept, you just smile, because here's all you have to do. I want you to highlight the y-axis. The little y at the top is going to help you out. There's the y-axis. And then the point where the line touches that, that's the y-intercept. So right there, that is where the line touches the y-axis, and that is 3. So that's your y-intercept. That's all you have to do for the y-intercept. Let's do one more example together. You're getting really good at slope now, aren't you? So this is a real world situation. It looks like we're renting a bicycle. The graph shows the cost in dollars to rent a bike for X hours. Find the slope or rate of change and the y-intercept. Let me highlight this here because we have slope and rate of change. Y'all, those are the same thing. Slope is just rate of change on a graph. Rate of change tells you how your X and Y values are changing. And when you look at that on a graph, it tells you how steep your line is. So those are synonymous. They mean the same thing. They refer to the same value. Then we also need to pay attention to our y-intercept. Let's do the y-intercept first this time, because do you remember what we said about the y-intercept? We said it's easy to find. So let's highlight that y-axis. Remember, we're just looking for that y. There it is. And then our y-intercept is going to be 5. Go ahead and write that down right there. We'll talk about what that means in just a moment, but first let's find the slope of this line. So let me model the other way I found slope so that you know that you can do that. I could use my little staircases, right? I could go up, let me make my pen bigger. I could go up 5, and then I could go over 2. Now you might be thinking, wait a minute, you didn't go up 5, you went up 1. I did go up 5. When you're working with a real world scenario, you have to pay close attention to the intervals of your axes. And in this case, my y-axis is counting by 5s. 0, 5, 10, 15, 20. So I went up 5. And then I went over 2. And in both cases, I have a positive value here. And we can affirm that by looking at our line and seeing as we go from left to right, it's going up. so our slope is positive. So I have not used a formula at all, and I already know what my slope is. My slope is going to be 5 over 2. But I don't want you to just take my word for it, so we are going to use our slope equation as well to show that. So let's do it. Remember, it didn't give us any points that we have to use, which means we get to choose. So let's choose these two right here. We have 0, 5. Let's label that. It's our y-intercept, right? And then we have 2, 10. That's right there. So those are the 2 points I'm going to use because I've already used them. Okay, label my x1, y1, x1, y1, x2, y2. And remember, it doesn't matter which one is 2 and which one is 1 as long as you're consistent. Okay, so let's do it. We need to do y2 minus y1 over x2 minus x1. Have you guys noticed that I write that a lot? I want you to write that a lot too. Whenever you calculate the slope using the formula, please write the formula down. Okay, y2 is 10, y1 is 5, x2 is 2, x1 is 0. Beautiful. 10 minus 5 is 5, and 2 minus 0 is 2. Look at that. There it is. Just like we knew we would get. 5 over 2 is our slope. So we go up 5 and we go over 2, up 5 and over 2, and we will always land on the line. Now we need to talk for a minute about what all of this means. It's not enough to be able to calculate the slope and find the y-intercept. In the real world, this is going to have real meaning, and you're going to need to know what it is. So let's go back and remember our context. The graph shows the cost in dollars to rent a bike for X hours. I am going to underline that because that's important. My X is my hours, and then my Y is my cost. Okay. So what we're doing here is comparing the amount of money we have to pay to the amount of time that we rent the bicycle. So then what would our slope represent? That's going to represent the hourly cost of renting the bicycle. It might actually be easier to see if we made a table of points. Check this out. So here we have X, we have Y. If we just rent the bicycle, but then we turn it right back in, we actually have to pay money to do that. At 0 hours, we've already spent $5, right? If we just, I suppose, say, hey, can I have the bike? We pay for it, and then we say, never mind, I don't want the bike. It still costs $5. Kind of a bummer. Okay, now let's go over to 2 hours. If we want it for 2 hours, it's going to cost $10. And if we wanted it for, it's actually kind of hard to tell how much it would cost for 3 hours, right? This is 3 hours. I'm not going to use that point, though, because it's not a pretty point. But I can use this point right here. 4 hours would be 15. So if I wanted to rent it for 4 hours, that would be $15. And what I can see here is that when the amount of time that I rented it increases 2 hours, the cost to rent it increases $5. When my time increases 2 hours, my cost to rent it increases $5. So this 5 over 2 that I found, what that really is, 5 divided by 2 is 2.5. It cost me $2.50 per hour to ride this bicycle. That's how much it costs for each hour. But remember, we said that at 0 hours, it already costs me $5, right? So how could that possibly be right? Y'all, that is because there is a fee. Just to rent the bicycle, there is a $5 fee that I must pay, and that is the Y-intercept. So there's a $5 one-time rental fee. The problem didn't tell us that, but we figured it out because we knew that 0 hours was the same as $5. So we were able to use just our math and our understanding of linear relationships to figure out exactly why it was $5 at 0 hours and what that $5 must be. So good job, us. All right, and now you have some time to practice finding the slope and the y-intercept from a graph.